In this video, we will develop our understanding of exponential functions and growth factors to consider how to make meaning of growth factors when the input quantity in an exponential function increases by an amount other than 1. Recall that if two quantities change together in an exponential way, then we can model this situation with an exponential function, and the output quantities will show a constant percentage change. This means that when the input quantity changes by the same amount, the corresponding output quantities can be determined by multiplying the previous output quantity by a constant growth factor. In number 10, in Module 4 Investigation 3, for example, we know the relationship is exponential, so we can determine the growth factor when increasing x by 1. And we can figure this out by knowing that this growth factor will always be 299 divided by 260, because if we multiply 260 times 299 divided by 260, then we will get 299, the next output value. Also, if we multiply 299 times 299 divided by 260, we obtain the next output value, which is 343.85. In fact, when we increase the input by 1, the next output value will always be 299 divided by 260 times as large as the previous output value. With this fact that we know about exponential functions, consider question 1 in Module 4, Investigation 4. Are the proposed output values of 42 and 46 correct if there is an exponential relationship between x and y? Explain why or why not. For question 2, the problem asks you to think through what the population of a county will be if it doubles every 20 years. Carefully answer each question in this problem. Know that the parts of the question will build on one another, so don't get too far ahead of yourself. Show patience and only answer what is being asked in each part as you go through. Also, note in part E that n represents the number of 20-year periods that have elapsed since 1990. N does not stand for the number of years since 1990. Finally, question 3 asks you to consider the same context as question 2, where a population doubles every 20 years. But it asks you to think about how much a population that changes in this way will change over smaller periods of time. We know it takes 20 years for it to double. So what does the change look like over 10 years, or even over just 1 year? Remember that the population is still growing exponentially. Read each part of question 3 carefully and provide your answers. Submit your answers to all parts of questions 1 through 3 in Module 4 Investigation 4 using your instructor's preferred method by the time and date that your instructor has identified.